Okay, in today's video, what we're going to be talking about are like terms. So in algebra, what you have to do is you typically have to collect like terms. So you're going to see that phrase a lot. So you're going to see the term or the phrase collect like terms. Okay, now what are like terms? We need to discuss that. So like terms, okay, are terms that have the exact same variable along with exponent. Okay, so for example, 3x and 4x have the exact same variable. The variable is x. They both have x. On top of that, they both have the exact same exponent on that x. When you don't see the exponent, it's 1. It's an imaginary 1 there. Okay, so these two have x to the 1, so they are like terms. Okay, well, we call this part, the part with the exponent and the part with the variable, we call that the literal coefficient. Okay, so if it has the exact same literal coefficient, it is the exact same, it is a like term. Okay, so these two have the exact same literal coefficient. So what I can't say then is that 3x and 4x squared are like terms. They are not, because one of them has, let's discuss some similarities. So both have x, but one has x to the 1 and the other has x to the 2. So these aren't like terms. Likewise, I can't say that 3x squared and 4x cubed are like terms either. They are not. Okay, so these aren't examples of like terms. What I can say though is that 3x squared and 4x squared are like terms. They have the exact same variable and the exact same exponent. Thus, we say they have the exact same literal coefficient. Therefore, they are like terms. Okay, so we can collect them. All right, so what the hell does collecting mean? Well, collecting means you either add or you subtract the two terms. Okay, so for example, we got 3x squared and 4x squared. Let's say we add them together. How do you add like terms together? What you have to do is you have to simply add the numbers in front of the literal coefficients. Okay, so you have to add the numbers in front of x squared like you would in first grade. So you'd go 3 plus 4, and that is 7, and then you merely place the literal coefficient next to it. That's it. 3x squared plus 4x squared is 7x squared. That's it. That's how you collect like terms. It's like saying 3 apples plus 4 apples is 7 apples. It's the same concept, all right? Except we go a little fancy since it's algebra and we add a variable and some exponent and whatever, okay? But it's the exact same idea. What you've done in grade 1 culminates here in 9th grade, I guess, with like terms and variable like terms and variable addition. Okay, so 7x squared, there you go. So how would we add 3x squared or subtract, let's say, 3x squared minus 4x squared? Well, you go 3 minus 4, which is negative 1x squared. You can alternatively write this as negative x squared. It's the exact same thing. These two are equivalent. Okay, you can do the exact same thing by not writing the 1 there. Okay, it's just by convention. Okay, this is how we write it in math. We don't have to write the negative 1. You could just write minus. All right, and yeah, that's essentially collecting like terms. You have to have the exact same variable along with the exact same exponent in order to collect them. That's what we call like terms. All right. And yeah, all you do is you add or subtract the number in front of the literal coefficient, and that's it. It's pretty standard. And I think in the next video what I'll do is I'll do some complicated distributive property. I'll introduce distributive property, then I'll do some algebra to collect like terms and simplify expressions. That'll be in the next video. But this was just an introduction to, you know, what makes like terms, and I guess collecting like terms, because this has to be rounded. I've seen a lot of students do the following. So they'll get an expression that has this, and then they'll go 3 minus 2 is 1, and then they'll go x to the 2 minus 1, as if they're doing power laws. You don't do that, okay? These two are not like terms. X squared and x are not the same, okay? The second you have a different exponent means you have a totally different type of term. They're not like terms in that case, okay? So just keep that in mind, and yep, I'll see you in the next video. Peace.